So we also included a series to take into account possible changes in technology over the study period, and also error term to take into account. So some of the estimation issues that are likely to confront one when you want to estimate such system of equations are, for instance, multi-crop production theory implies that production decision of one crop is likely to be associated with the decision of another crop. And then there are contemporaneous correlations in error terms. So usually the error terms for each of the equations are expected to be correlated. Then the variances and covariance equations are nonlinear and endogenous in our supply response equations. So and there's usually cross-sectional dependence. So the idea is that since you're looking at a region in which the cropping system, the rainfall pattern is similar, you understand? So you expect some cross-sectional dependence in the modeling. Then, of course, we used, so based on these issues that may likely arise, we used nonlinear least squares regression technique, as well as similarly unrelated regression estimation technique. The nonlinear regression estimation techniques were first used to estimate the variance and covariance equations, and then the predicted values of those estimates were now used as instruments in the supply and demand equations. So some results that we decided to share. So we left out some of the variables that we feel are not the focus of this study. So immediately what hits one is the fact that most of the coefficients are not statistically significant. And we feel that the reason why this is so is because if you check the trend of the output data we showed you, it did not really correlate with the stochastic nature of the weather pattern we showed. And we feel perhaps that is because of the poor quality of the data. Ideally, it's supposed to also mirror or mimic the variability that you see in the rainfall pattern. But however, the direction of impact estimates we feel is very important. So, for instance, for the normalized variance of ground rainfall data in April, that is IVGRAP, it shows that weather in that particular month impacts negatively on expected output, right? So the idea is that with this kind of results, one should expect that the decision of the farmer at the beginning of the cropping season, you understand, is very important, because it means that the risk of rainfall anomaly at that period is high. Likewise, if you see the, just for instance, one of the variables LEGRAP, so is the normalized expected ground rainfall for April, right? So you see that the negative sign there indicates that there is a mismatch between the expectation of the farmer about how the rainfall pattern will be in that month and the actual rainfall realization. So that also impacts negatively on the crop production decision. So that was how we interpreted our results. These are an extension of the results that we had. In particular, the R-square indicated that the fit of the model in general is okay, despite the fact that most of the variables are not statistically significant. So we conclude that accurate weather forecast on the start of the rainy season when sowing is done is very important, particularly for the measure of, for our measure of rainfall expectation by the farmers, which is given by the mean expected rainfall, right? So anywhere we see a negative relationship between expected rainfall and output, it means that there's a mismatch between rainfall expectation and output, and therefore adequate and correct weather forecast, you understand, can help the farmer decide, right, the nature of the rainfall pattern at that particular point. So, and also climate index insurance also helps, also presents opportunity to manage weather risks. So given the fact that each of these crops have different, water needs and phenological features, the previous agricultural insurance mechanism, which is, based on general agricultural output, may be inadequate. So index insurance may be useful. Then an introduction of cultivars that are more resilient to adverse weather. Thank you.
Okay. Thank you, Mr. Yusuf. Now we're going to give the floor to Alicia, Dr. Alicia.
Thank you very much, Dr. Yusuf, for your very interesting presentation. A lot of interesting ideas. So I had several suggestions for your consideration for the future of this paper. First is we know that millet and sorghum are already drought resistant. They are relatively these are the crops which are suited to these environments, to more dry, drought-resistant. So when we are suggesting about other cultivars, so some idea what could be even more drought-resistant, in sense more tolerant to this variability, would be a good idea to think about. And in that perspective, it would be good to see, I think, these supply response options. What is the substitution between crops? So we can see that there is some decrease in sorghum or a decrease, but what's happening then? What is getting planted instead of these? Or you mentioned also there is cowpea or groundnut. So if there is more rainfall and people people may switch from this drought-tolerant sorghum and millet to other crops. So some sort of idea what's in terms of substitution between crops to be included in the paper would be, I think, enriching the paper a lot. And then some other areas which you could consider is relaxing some of the assumptions, like about you're assuming a risk-neutral decision-making process. What happens if farmers are risk-averse in their decision-making? How it may change the results, and then stationarity. I'm sure you did stationarity tests and cross-section dependence. So another approach would be just to remove this. If you find there is this unit root, and then you remove that, filter out that part, and then use more standard approaches on the stationary part of the time series. And then, at least for me, it was not clear why you're dividing one price by another price. So some more explanation of that at least would clarify what you want to do. And my final point is, but before that, just a small technical thing. It would be nice to write out variable names in the tables to make them a little bit more understandable. And final point. Since you are looking at the mean yields and then their variance, why not explore a bit more applying different stochastic production models like JustPop or others which could perhaps provide an additional angle to your analysis or strengthen them from a different, to give you a different perspective on that. These are just some suggestions for your thinking and consideration in your future work on this paper. Thank you.
Okay. Thank you, Alicia, for the comment. I also add some comment to the presentation. I didn't see.
Are we discussing them? I thought we should have discussed them at the end.
Yeah, we will.
So we leave it because I need to into time.
I'll handle that. I'll handle the time. So I may forget. That's why I am actually those things directly. So I didn't see well where do you base or from which literature do you draw your modeling from? Because in economics we built our models from the literature, but didn't see you telling us from which literature did you draw your modeling from. Okay, because at the end we see that actually most parameters are not significant, which raise some question even though the R-square are so high. So I'm just raising those concerns so that you can think about that. So we go next to the next presenter, who will be Mr. Jawala William. Is he here? Please, can you move forward? You have 15 minutes to present what you have, and then we'll have also Dr. Alicia coming in for discussion. Okay. So you can start. Have 15 minutes. Garba?
Good afternoon, Mr. Chairman, and good afternoon, colleague participants. I am William Ajaura, and I wrote this paper with some other co-authors, Musa and Nikes. So our paper is on climate perceptions, farmers' willingness to ensure farms, and resilience to climate change in northern Ghana. So, in Ghana. All right. So I'll follow through introduction, a bit of discussion on methodology, present some results, and go through the conclusions and recommendations. All right, so there is enough scientific evidence to suggest that climate change is real and its impacts are gradually worsening into the future. The case of Ghana is not different, especially in the northern part, as the rainfall pattern is becoming more erratic with associated climate shocks such as drought and floods. What is evident for farmers to do is to therefore adopt some specific climate adaptation strategies that will improve their resilience to climate change and ensure that their livelihoods associated to farming are improved or at least maintained. One of such adaptation strategy that is less promoted or less used by farmers is climate insurance. And this is simply because these insurance policies are non-existent or less developed, especially in the developing countries and the case of Ghana. But what is known is that climate insurance can at least reduce the impact of climate shocks or risk, or at least it is a cost-effective approach to ensure that the social support needed for farmers are maintained. There are considerable studies on analyzing farm insurance among farmers. But what is also missing in the literature is the failure to include especially climate shocks into such models, and the inability to move beyond the decision to analyze the risks, the decision to ensure farms, and estimate the impact of such decisions on climate resilience. So this theory attempts to move beyond the previous studies and to analyze the effect of the decision to ensure farms on climate resilience of farmers. So the study is conducted in northern region of Ghana, and this is one of the 10 regions of Ghana, the then 10 regions of Ghana, now 16 regions. Temperature is higher in the northern part of Ghana than in the south, and the area also experiences one rainy season instead of double rainy season as in the south. The region is therefore noted as one of the climate vulnerable areas of Ghana, especially due to other developmental challenges such as poverty. So the study used a primary data, therefore we followed through some sampling procedure and data collection techniques. So the study adopted a multi-stage sampling procedure. In the first stage, we used the stratified sampling procedure to determine to put farmers in northern Ghana into 3 strata. We have using a poverty map of Ghana. This is to ensure that the differences in poverty are captured, since we are talking about insurance, which involves monetary issues. So we have poor districts, rich districts, and then middle class districts. We therefore use simple random to select one district from each of the cluster, the strata, and then proceeded to use simple random and select 3 communities from each of the districts, and then 23 farmers from each of the selected communities. Moving through this process, we arrive at a total of 209 farmers. As indicated, we used primary data, and this data was collected using a pre-tested questionnaire. Okay, the study used the double-header model to estimate the willingness to ensure farm, and then an other probit to estimate the effect of insurance decision on climate resilience. This followed the contingent valuation theoretical underpinnings that says that in cases where there are non-market, market is non-existent for some goods, we have to provide some hypothetical market and then proceed from there to estimate our economic decisions. So building on such theoretical backgrounds, we develop an empirical model where Y stands for both decision and amount. So the first equation that is on the double-header model is estimated with a double-bounded decisions. So the first decision is a probit decision, and then the second is a truncated 2-bit. So the second part of our analysis is the other probit. In this case, climate recovery is used as a proxy for climate resilience, because the faster the farmer is able to recover from climate shock, the higher the resilience. So in other words, the higher the recovery, the higher the resilience. So we use recovery as a proxy for resilience. And this is also based on the subjective approach of measuring climate decisions, since the farmers are allowed to determine their own level of recovery instead of following an objective approach where we have to systematically identify some indicators and then compute. And so we also model this based on some identified socio-economic variables that are guided by the literature. On results, our data revealed that over 50% of the farmers were willing to insure their farms. And we also made an attempt to go to some insurance institutions. We went to 2 insurance institutions and then 1 bank in Ghana, specifically the Agricultural Development Bank, that's more working close with the farmers to see if they are also willing to provide insurance policies to farmers. But the reverse happened with the insurance institutions. One of the insurance institutions is willing to provide insurance policies, but the other is not. And then the Agricultural Development Bank is also not willing to insure their funds. But what we have also realized is that the farmers were willing to offer a higher amount than the insurance policy, the insurance institution that is willing to offer insurance policy, which is an indication that there is a market, there is an economic incentive for providing farm insurance policies to farmers. So this is the result for the double-header model, where we have the result for the decision to insure farm, and then the amount farmers were willing to provide as farm insurance. So our results suggest that farmers who experience more of flood and drought were significantly willing to insure their farms. But when it moves into the amount the farmers were willing to pay, this decision becomes insignificant. This is because as the farmers experience more of drought or flood, they become so risk averse and therefore tends to move towards taking some of these non-on-farm adaptation strategies that will improve their resilience to climate change and ensure that they maintain some level of livelihood. Unfortunately, we found that farmers who were or had an information on the shocks before they occur, they were not willing to insure their farms. But what we realize is that as the farmers become aware of shocks before they occur, they may take some pre-measures that will ensure that their farms are not affected much by these climate shocks. Which also suggests that providing shock information or telling farmers more about climate shocks before they occur is necessary. Okay, so the effects of farm insurance on the resilience of farmers. So the resilience of farmers is measured on a 5 scale. Farmers who recovered in the same season, farmers who recovered after 2 seasons, those who recovered after 3, and those who, from the literature, those who recovered after 3 seasons are said to be non-recoverable. In other words, they did not recover from climate shock. And so our result on the willingness to insure farms suggests that farmers who were willing to insure their farms recovered in the same season than farmers who were not willing to insure their farms. This is an indication that providing farm insurance to farmers will actually build the resilience of farmers to climate change. On conclusion, we want to conclude that most of the farmers were willing to insure their farms and were also willing to pay a positive price for farm insurance. And at the same time, there is a market incentive for providing farm insurance policies to farmers, since the financial institutions may get more profit from providing farm insurance policies. Climate shocks had a positive effect on farm insurance decision, but shock awareness had a negative effect on insurance decision. But I put the two of them as positive because the insurance, in terms of real interpretations, the effect of shock awareness is a good, the negative effect of shock awareness in the model is it's a positive decision that needs to be promoted. Overall, the observed frequencies and predicted probabilities show that farmers recover, most of the farmers recover from climate shocks either in the same season or after a second season. We also want to conclude that farm insurance is an important strategy for making farm households more resilient to climate shocks. So what do we do with our results? There is a need to introduce farm insurance policies to crop farmers in the region. But in order to ensure that the farmers remain loyal to such insurance policies, an appropriate premium should be determined not only by the insurance providers, but in consultation with the farmers to ensure that both farmers and insurance providers obtain a mutual benefit from insurance policies. On this note, we thank you.
Thank you, Mr. William, for the presentation. Very interesting presentation. I have the following suggestions for your paper. First, it would be very, I think, useful if you enrich the theoretical part of the discussion, particularly differentiating between the covariate and idiosyncratic risks that farmers can be exposed. Because insurance can be very good dealing with idiosyncratic risks, but if you are only looking at specific region where risks coming from climate, extreme weather events could be covariate, then it may pose problems for the insurance part. Second suggestion is to have some more robustness check to the identification strategy, specifically related to the how account for potential unobserved variables in the models that may be correlated with decisions to insure and that may be introducing some bias to the model. Some sort of more convincing identification strategy description could, I think, make this paper very even more interesting. So if I understood well, you said that farmers are willing to pay more than the insurance companies were asking for premium. Then the question is, then what is the problem? So if farmers are willing to pay more, even more than what insurance companies are charging as a premium, then why it's not spreading very quickly? It sounded a bit counterintuitive to me that perhaps you may want to clarify those aspects. And last point, perhaps in the narrative, to make your paper very enrich the discussion in the paper is now you are looked mostly from the demand side, so farmer side, whether or not they are willing to pay, how much. Perhaps some ideas, some brief discussion about the demand side supply side issues. So what are the issues with the insurance providers? Why they are, what would take them to provide more insurance? So some sort of ideas about these problems and opportunities from the supply side perhaps will give a well-rounded discussion of this issue in the paper. Thank you.
Okay, thank you, Anisha. We'll move fast. So we started late, and so I assume that we will not also end on time. So by probably 15 minutes more, instead of finishing at 12:30, we finish at 12:45.
Chairman, we are going to dive down into the last. We have 30 minutes somewhere there. General discussion. So why into that time?
It is
from 12:05 to 12:30.
yeah.
So why into that time?
Yeah, it's already 12.
Yeah, the other only
Yeah. Okay. So this is Mr. David Awolala.
Yes, David.
Okay.
It's my pleasure to be here this afternoon. My name is David, and I'm producing this paper with Professor Alimbai and Professor Van Brown, which is a paper that is coming out as an extract from my thesis a few years back. And the title of the paper is Weather Index Insurance Sufficient for Smallholders Protection? Insight from Rainfall Index Calibration of Maize Losses in Central West Africa. What is the motivation for this study? Basically, the idea is, across developing countries, over the years, smallholder farmers have what we call autonomous adaptation. Without being told, they've learned some skills on how to adapt. But over time, there is something we call residual impacts. That is, no matter how they tend to adapt, the residual impacts will still be there. And so over time, because of increase in weather extremes or uncertainty, now residual impacts are becoming larger and larger. And there are so many failures that have come around traditional crop insurance. We have several authors, several speakers who have talked extensively about traditional crop insurance, but we know that there are a lot of failures with traditional crop insurance. So the problem now is for scientists and policymakers, how can they assist these farmers to get protected so that they can attain resilience? Because more and more, they are becoming more poor in terms of their adaptive capacity. So the idea of weather index insurance comes up because relatively in terms of transaction cost is cheaper. Insurance providers no need to go to everybody's farms and start measuring physical farmers' losses. Rather, what is binding communities, for example, is a weather shock, say a drought risk or a flood risk somewhere. And so this covariant risk are being measured in terms of payout. And once we have a threshold or an index that is agreed by the farmers, by the insurers, and other stakeholders, then payout is confirmed. But over time, because of certain issues that are peculiar to developing countries, we have weather index insurance being applied in some countries like Malawi, like Ghana, Senegal, or Kenya. But in Nigeria, I want to bring out some insights. If really rainfall index calibration of, say, maize losses in Central West Africa, West Nigeria, really worth it? So I have this as my presentation outline, and I will go straight to my research problems. Like I said, across most African countries, weather index-based insurance is expected to correct failures of traditional crop insurance. Yet, it's not clear if weather indices reliably serve as proxy in calibrating maize losses, especially in Nigeria. And so I have these two research questions. Do rainfall deficits justify weather index insurance in the middle belt of Nigeria? Could basis risk be possibly minimized through correlated indices for insurance contracts? So this study examines patterns of rainfall distribution in the Savannah middle belt. I also, we tend to analyze trend of maize yield during wet season and rainfall, and also to determine correlation of rainfall indices with agricultural losses for drought risk transfer. So the study was carried out in the Savannah middle belt of Nigeria. That region is 50% of the entire land surface of Nigeria. It's very huge and vast. And in fact, it is the most luxuriant and extensive vegetation zone. It accommodates production of all various kinds of food crops in the entire country. So that region is very sensitive to the issue of food security in Nigeria and the entire sub-Saharan Africa. So these data that were collected were based on secondary data, and they were obtained from, especially the rainfall data, daily rainfall data, were obtained from Nigerian Meteorological Agency, which is from 1981 to 2013. And also we have yield data, maize yield data, obtained from Kwara State Agricultural Development Agency, which is also from 1984 to 2010. And rainfall regimens were analyzed using some probabilistic models. We have 8 probabilistic functions which were fitted to see the variation in annual and seasonal rainfall pattern, and to evaluate which probability distribution functions best fitted the rainfall regimens. And also to find out the reliability of weather index as proxies for farmers' losses. Some correlations were tested with maize yield to have the best yield losses predictor, and also causal effect relationship of maize yield and selected 15 rainfall indices were fitted using linear equation. Now, according to Gine et al. 2010, usually one major problem with weather index insurance is how to minimize basis risk. So 2 methods were mentioned in literature. First is to detrend time trend of crop yield, which we attempted in this paper using linear and quadratic equations, which could be positive or negative. And also indices were constructed based on the phenology stages of maize production. We have 3 phenology stages: crop establishment, crop development, and flowering and reproductive phases. And some hypothesis was tested using Kolmogorov-Smirnov test and Darling test to see if cumulative rainfall across Central West Africa follows a theoretical probability distribution function. And these are the description of the rainfall probabilistic model functions. We have 8 in number, but the most fitted equation model will be presented in this work. Now, also this is a table showing the potential rainfall indices, which is meant to capture maize yield losses in the Central West Africa. We have 15 of those weather index variables. Now, to results, looking at the daily rainfall distribution over Central West Africa for 30 years, we found that our rainfall regimen is negatively skewed, meaning that most of our rainfall data are shifted to the right-hand side of the mean, and while the extremes were towards the left, showing that the region is gradually experiencing serious rainfall deficit in the region, which needed attention. And when we look at the second graph showing probability density function, we see that it follows Weibull distribution. Out of the 8 probability distribution functions, it follows Weibull distribution, which also follow literature that most regions of West Africa their rainfall pattern follows Weibull and Gumet distribution. But for the Central West Africa, it follows well-followed Weibull distribution pattern. The reference line. The reference line corresponds to the exhibited values for the threshold and May 30, that is the first 1 month, happens to be development.
effective means to achieve long-term conservation of nature. The implementation of protected area will put some restriction on access to forest resources for local population. However, this local population, especially poor population, they rely on forest-based resources for their daily livelihood. In Africa, for example, we estimate to 600 million people, those who rely on forests and woodlands for their livelihood. For our study, we will mainly measure the total benefit of conserving the bois-flex protected forest. More specifically, we will analyze the perception of surrounding population related to the bois-flex protected forest conservation. And secondly, we will evaluate the willingness to pay and the determinant of this willingness to pay. And thirdly, we will measure the total economic value of that protected forest. For the first objective, we used a questionnaire addressed to 159 households from 5 villages. And for the second objective, we use the contingent valuation method, especially the willingness to pay. And we analyze the determinant of this willingness to pay by the Ekman model. For the third objective, we use the total economic value approach developed by Peace. And this approach split up the total economic value in use value and in non-use value. For the use value, we use the direct use value, the indirect use value, and also the option value. For the non-use value, we use the existence value, the fact that the forest exists, what benefits to population. And also the bequest value is the benefits of the forest in terms of heritage. And for the quasi-option value, we use the future existent value and bequest value. So for the use value, for our study, we use the willingness to pay, and we add some computation related to the indirect use value in terms of carbon sequestration and also the benefits in terms of water replenishment. For the non-use value, we use estimates provided by the literature. Our study area is the bois-flex protected forest in the western part of Côte d'Ivoire. It is one of the most deforested protected forests, and it is a secondary type forest with 20,350 hectares. And for the first objective, to analyze the perception, we asked to our sample about some questions, and 94% of our sample size recognize that forest it is important to protect the forest. Within this 94%, they recognize the role of forest related to livelihoods in terms of food at the rate of 95%, and in terms of medicines at the rate of 97%. They also recognize the role of forest related to agriculture at the rate of 95% and to hunting at the rate of 62%. So they also recognize the role of forest related to climate issues. For rainfall, they recognize that forests contribute to increase the rainfall occurrence at the rate of 94% of the sample size. And 83% recognize that forests provide, reduce the heat, the local heat. For fertile soil, 78% recognize that forests contribute to provide fertile soil for the economic activities. For the second objective, we estimate the willingness to pay, the median one, which is 1,000 CFA francs, around 1.5 euros. And for the mean willingness to pay, it was estimated to 1,658 CFA francs, which is estimated to around 2.5 euros. So we came with 42% of zero willingness to pay, which is mainly due to lack of money, at the rate of 58%. Of those who respond, they don't have money for paying. For the determinant of the willingness to pay, we use some variables, socio-economic variables, and with the Ekman models, we came to the result that first, the probability to be willing to pay is determined by variables like the origin, autochthone, and the age. So autochthone and older household heads, they are more likely to be willing to pay for forest conservation because they have been staying there for a long time, so they develop a kind of link to the forest. So cultural values are an evidence here. The level of studies will increase the likelihood to be willing to pay for forest conservation because education is open the mind of people to forest conservation and environment conservation matters. The more the farmland is huge in surface and the more the family labor is, they are more likely to be willing to pay for the conservation because they want to secure their activities and also they have purchasing power to do it. According to the second stage of the Ekman model, we applied an ordinary least square method of analysis, and we came to the result that the original autochthone level of studies are still increasing the amount of willingness to pay, and the revenue also of the household heads will increase the amount is willing to pay for forest conservation. When the main activity is agriculture, they are more likely to invest more in forest conservation because they want to secure their activity. And when the farm is inside the protected forest, they don't want to participate in the conservation because they see this conservation as a threat to the maintenance and the presence of the farm. The age here, in fact, affects negatively the amount of willingness to pay because the more they grow in age, they don't have too much resources, financial resources to invest in the conservation. About the indirect use value, we compute the groundwater replenishment, and for that we use the recharge of the groundwater of Fiedler, which is around 200 meters, and we times to the shadow price of water, the drinking water in Côte d'Ivoire. We use the price of the company in charge of management of drinking water. And so we came to the result that the benefit in terms of water replenishment is around 461,000 billion CFA francs. And according to the carbon sequestration, we use the estimate of FAO, and we times to the CO2 equivalent factor and the price of certified emission. And we came to the result of 56 billion francs CFA as the benefit in terms of carbon sequestration. So by adding indirect use value, the estimate in the literature, we came to the result of the total economic value of the bois-flé protected forest to be 462,408 billion CFA francs. This amount of the total economic value is around 775 times higher than the benefit in terms of timber production. So we can see that the conservation is important because the benefit we can obtain from that conservation is highly greater than the one with timber production and selling. So as policy recommendation, we recommend intensive agriculture to the stakeholders, and also we encourage them to incite agriculture to use this intensive agriculture in order to reduce the pressure on new land for agriculture. And for the zero willingness to pay, we could sustain forest conservation by developing alternative economic activities for local population. For example, we can develop ecological tourism so that they could have alternative activities and they could reduce their reliance on forest-related activities. And we also encourage the government to use the participation of local population in the design and implementation of policies. So we encourage a bottom-up approach and listen to local population and also their will. And so we can encourage them to adopt some ecological friendly innovative strategies like the use of cook stove and also biofuel. Some limits for this study is related to the zero willingness to pay. And to afford this, we can use the time allocated to the conservation. We can ask local people about the time they could allocate to the conservation activities. And we can monetize it. And secondly, for the indirect use value as the carbon sequestration estimation, we can use the vegetation cover distribution so that we could have a more accurate estimate for carbon sequestration. We acknowledge WASCAL for granting us the PhD scholarship. From there, we graduated. Thank you for your attention.
Thank you, Kwame. Now turn to Alimentaire. Comments?
So, first of all, my congrats for you, Nadej, for your presentation. Yes, it was interesting to see that instead the perception for the conservation is very high, but the willingness to pay for that conservation is stay weak. This can be related, as you put on, for example, to the education level, but I would like to suggest you, if, for example, if you, I didn't perceive in your work is you stratified the groups that you are searching. For example, when we did the questions about the perceptions of, and the questionnaire related to the willingness to pay, if you divide in different strata, maybe this can give you better results because, for example, the level of education or the level of incomes of the population maybe can present different results. The people that are more engaged, that have better works, and so maybe they of course, they are. The willingness to pay would be better. The ones that is more dependent of the florist, instead they have all this perception of the benefits of the florist, they give them, but they cannot afford for the payment. For us biologists, it's difficult to make to see monies around, to see finance around the benefits of the nature, to put it in finance, but we understand, of course, that is important, especially because in some moment I hear that maybe instead of Homo sapiens, you should be called Homo economics, because our mind is made more around money than sapiens. Yes, it was an interesting point of view. So it's also, my suggestion is maybe next time divide in different strata, maybe your results can be improved on that. Thank you.
Thank you, Dr. Almeida. Thank you for the comment. Now is the time for discussion. We will have the four presenters coming forward. I know we have only two chairs here. And so, Mrs. Kwame, can you come forward? And I will choose one man between all of you guys. Ulala, yeah, please come forward. And so we have two other people who are sitting, and we will get back to them as well if they have a question for them. But we have only three chairs here, so we don't have a choice. So I will open now the floor for questions. If you have questions, we'll have probably 10 minutes for questions. And so I will ask people to be straightforward in asking questions so that we move fast. Yeah. So the floor is open for questions. Yeah.
First person on the study of Ghana. Okay. Study on Ghana. William. Is it there? Yes.
It's okay. Well, move forward. Just sit down at the front. Yeah, that's fine.
Well, look at it there. Yeah, you can just move closer. Well, we're going to make it as fast as possible. The issue is, I think we are not too sure of the area of coverage of this study. If you look at the study, it talked about Ghana, but inside the work, it talks about northern Ghana. The entire work is on northern Ghana. You can look at it. So there's need to revisit that work and tell us specifically where that study is based on, it's coming from. That's the key thing I saw there. For Yusuf, I was very confused about your variables. I'm not too sure that I could tell what the X is represented and why you decided at any point in time to look at it. But I know that you talked about expectation. You are the one who had the rainfall. we are supposed to have had last year's rainfall affecting tomorrow's farm decisions to plant. If you had good rainfall last year, it is possible that the decision to plant will improve and more farmers will be engaged in it. What of prices? Supply. The supply response curve normally talks about current and past. I didn't see you discussing the issue of past price affecting farm decision. It's very critical. Because if I want to grow maize and the price of maize this year was so good, I'll be influenced to plant maize next year when the season comes. And I now also notice that you were talking about annual rainfall. But annual rainfall has a residual effect, which I was present. So I also would have loved that you build your expectations as your rainfall, when you are doing your research, you carve out Fadama-like soils. Because if you don't, then you have a challenge. Because that's what actually this lady from Cape Verde was talking about. Lower rainfall, but the residual rainfall can tide over. After all, maize is an 80-day to 90-day crop with the most current varieties. So you could get a residual rainfall to capture, be able to keep hold water for 80 days or 90 days. So you need to look at it. I thought that is who, I think one of them is Sisa. Then the person on recovery, something about, is that insurance? The person on insurance. I'm not too sure I knew what you meant by recovery as and how did you measure. The variables were completely not defined at all. Say recovery as an endogenous variable to a model. How did you define this thing? Look at how you define those, all your exogenous variables. Age, you didn't, there's nothing. Normally, there's no model for which you want to run that should not make me know the variables and how you define them. Because the way you define the model will give me an expression of what results to expect. So you look at it very carefully. All right, the other one on is whether index is sufficient for smallholder protection. There are a few things I said about it. It's a question, and so you must answer the question. That's the study. It's a question, so you must answer that question. So, the Kwara State data cover the entire central region of Nigeria? Because I heard you talking about collecting data from the Kwara State, I don't know if it's ADP. Was that data covering Nigeria, or was it only Kwara State data? It is not, so it didn't cover Nigeria, it could not have covered the entire area. There are variations. You must look at what you are doing so that someone else will not question it. Now, we talked about weather index. What are you indexing it? Over a year or over the crop itself? Because an index is, you must have a base. What was your base? So look at it. And I then ask, what of the availability of the Fadama-like soils? Did you look at it and separate it? How did it add to your study? I think for the lady, I loved your work, especially when you put the value of that forest at 400 and something billion. I would just go ahead and tell all my people, they don't need to work. Oh, they are funny, because they will be earning far more. And so I thought that we should be talking about issue of marginal private benefits and marginal social costs. Well, anytime the marginal private benefits seem to be lower than the marginal social costs, you see people wanting to exploit because they don't know. The prices are higher than what they should earn, so it will. So this government now is the one that will now need to pay the difference. Of course, you made that analysis that we should pay. We should pay the difference between what they are having and what they should have. That becomes the incentive to retain your forest. So I don't know how you will incorporate it, but it will be a good thing to look at those benefits. Thank you.
Thank you, sir. So we'll take also 2 more questions before I give the microphone to the presenter to respond. So let's take one person here, the other person here. And then can we take one person also on this side? So let me take this side. There's no one here. Now, okay, then we take the second question.
Okay. Thank you very much. I have just one question for my brother that presented from Ghana. Now, the question I have is about the ordered probit model. You said, I want to assume from what I understood from your work that farmers' recovery periods were the dependent, that was the dependent variable for the ordered probit model. So you're attempting to check the potential effect of their willingness to insure on their recovery period. I have a clarification that I want you to make on that. Now, since they have not insured, you are checking whether they are willing to insure. How could that have effect on the recovery period they already had? So that place was a bit confusing for me.
Okay, thank you, Chair, for giving me the floor. My question also goes to Williams. One of your key findings is that in Ghana, the majority of farmers are interested in climate insurance, agricultural insurance. And if that is so, why is it that agricultural insurance, the implementation of agricultural insurance is not a reality, especially in West Africa? What are the challenges that are handling the implementation of agricultural insurance in West Africa? Thank you.
Okay, so I'm going to leave the floor to Yusuf presented. I'll start from my friend Yusuf, who's sitting down there. So to respond to one of the questions that I asked.
Okay. Yes. I actually took into account in my measure of weather expectation. I actually took into account the past realization of the weathers in a particular formula which I specified, although not included in the presentation. So it's actually a measure that is weighted over 3 past weather realizations. So it's actually a measure that actually takes into account previous weather realizations. I also want to comment on the observation by my major reviewer. The comments on explicitly making my variables clear is well taken. The other comment also on trying to estimate other stochastic models like Just and Pope to enrich the analysis is also taken. The assumption, the specification of my model is not actually a risk-free assumption. It's actually we're actually assuming that the agents are risk-averse. That is why we framed it within the context of the expected utility. Expected utility theory. If you see the measures of output is expected, it's not actual. So normally when an economic agent takes risk into account, his decisions is framed in terms of expectation. Yes. So the comment on also trying to explore how the substitutes with the crops, affect the analysis is also taken. Thank you.
Yeah. So question so that you answer the question in 1 minute so that we can go fast, because some people are already there and they are waiting for us to show up for the lunch.
Okay, thank you very much for the questions. With the topic, the stereo location is actually not in Ghana. So even when I was reading the topic, I said it's not in Ghana. Only to see that I put Ghana. So in the manuscript itself, it's not in Ghana. In terms of definition of variable, that is well captured in the manuscript, except that for presentation purposes, I don't want to put much load in the PowerPoint. Why is willingness to ensure use as a variable in the right-hand side? In the manuscript, I actually highlighted that this is used as a proxy for the actual decision to ensure, because the decision to ensure is already non-existent. And so if we have a willingness to ensure a decision, then this is the best proxy that we can use to actual willingness to ensure. In terms of supply side of policy, insurance decision as raised by Alicia and my colleague Kudugu, I think the problem largely is based on the risk associated with agriculture. Most insurance companies always tend to shy away from providing even credit to agriculture, farmers. And so insurance decisions also tend to face these market challenges.
Yes, I have two questions. The first one is that the data represents the which is Kwara State, but I also want us to know that weather index insurance is a site-specific adaptation tool or risk management tool. Is site-specific, so we do not have the data that covers the entire Central West Nigeria, but the state is key to Central West. That is why we capture it that way. And the data were collected in the northern part, which is the northern part of the state, which is completely dry. So there is no issue of fathomalized soil in that area. And the basis for our index, we use daily rainfall data for 1 year, and we also use rainfall data based on the phenological stages of maize. So that's the basis for the index from literature that we got, and that is exactly what we used. And finally, to answer the question, that is whether index insurance is sufficient condition for farmers' protection, the answer is no. We have other safety nets that should be bringing into the box. For example, our food security early warning system, social insurance for adults, and some other examples like that, like cash transfers that should be brought into the box, not just whether index insurance is too costly for farmers to use.
Okay, thank you, Professor, for your intervention. And obviously, the marginal private benefit will be different from the marginal social benefit due to the fact that the protected forest will provide positive externalities to local population. But we can put it in evidence. But who will pay for these externalities? Maybe we can think about policies to take them into account. I know that the carbon market try to do it, and locally maybe we should put in place policies so that local population could benefit from it.
Okay.
Thank you, sir.
Yeah. So we have to stop that here. I know that we can continue the discussion over lunch, so that we can respect the time and move forward. So we'll see you guys back after the lunch. Okay, thank you.
It was good. I love it.
show you my paper. I saw that in my paper. So yesterday, the paper on the
It will make sense.
Yes, I've noticed that.
No, very interesting.